All right, hey, Jalen and Jake, we are starting chapter or semester review today. They decided they wanted to go front to back, so that's what we're going to do. We're going to start with chapter 1, and we're going to try to get at least 15 problems done today, tomorrow, each of the days, right? Until you guys will take this test on Thursday. Not Thursday, Tuesday. Tuesday. I meant to say the T word, and it came out Thursday. Tuesday, and fourth period is before lunch, so it just goes normal, 2, 4, 6, 8, or 2, 4, lunch, 6, 8. So you guys will have this right before lunch, okay? 45 questions on the packet. You get to use this packet on your test, so we're going to write down any information that you would maybe need to know. You can add things to it if you would like, but I will make sure that you have everything written down that you need. You can use this packet on your test. There will be 45 questions on your test, but they will be mixed up. They will not be in chapter order like they are here. They will be mixed up, and they will be different numbers. You only have to answer 40 out of the 45. If you choose to answer all 45 and get every single question right, you get 105%. If you answer all of the questions and get 5 wrong, you would get 100%. Do you see how this works? Okay? Typically, I have a handful of Trig kids that get 100% or higher on the test. That's just the way that it works.
What if I miss 6?
If you miss 6, you would get a 97.
So our bonus is plus
Your
1.
bonus I don't count for 3 points.
That is crap. Sorry.
Right, because otherwise you would get 115%, and that's way too high. Okay, so anyway. Yeah. All right, chapter 1, here we go. Subsets of real numbers. This number 1 is going to take us a while because we're going to write down the subsets of real numbers, okay? Natural numbers, whole numbers, integers, rational numbers. Here we go. Off to the top up here, I'm going to put the real numbers. Every number is a real number except imaginary numbers, right? Except i's. The I-land lives over here. Imaginary. I-land, okay? But every number that you can think of that is like a real number is a real number, okay? Then we have subsets of real numbers. There are 2 categories of real numbers. They are rational, okay? Rational and irrational. Okay? Irrational has no subsets underneath of him, but what are irrational numbers? Pi? What else? Like the number E. Have we talked about the number E?
Nope.
E is in like compound interest. It's a number in your calculator. 2.71828 occurs in compound interest. We'll do that here, like maybe in January, February. We'll deal with E's and compound interest. Any square roots of prime numbers. So like the square root of 2 or the square root of 3 or the square root of 5 or any prime numbers that you're taking the square roots of, those decimals will continue on forever and never repeat. Okay? I'm trying to think of other ones that are irrational. Irrational numbers are decimal numbers that don't stop and don't repeat. Okay. Rational numbers is everything else other than that. Okay. Underneath of the rational numbers, the biggest subset is integers. Okay.
Oh, we have to.
Then underneath of integers are whole numbers. Then underneath of whole numbers are natural numbers or counting numbers. Okay, we're going to list off these guys, okay? Integers are like ... -2, -1, 0, 1, 2, ... They are like the whole positive and negative counting numbers. Okay? Whole numbers.
1, 2, 3, 4, 0.
You're close. 0, 1, 2, 3, 4. Okay? So it takes off all of the negatives. Okay, natural numbers are everything but 0, right? Okay, so they just take off 0. Okay, so what's considered a rational number that's not an integer or a whole number or a natural number? A fraction, 1/2. Okay, what else? 1/3. Like 1/3 would be 1/3 is technically 0.3 repeating. So if it repeats as a decimal, or it terminates as a decimal, so like 0.125 is technically 1/8, right? Okay, any terminating decimals or decimals that repeat or any fractions would be rational numbers, okay? If they are whole numbers, positive or negative, they're integers versus blah, 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 all that good stuff, okay? So those are all the subsets of real numbers. Got it?
Wait, so like...
Yes, what?
No, continue on.
Okay. All right. Okay, number 1, identify which subsets of real numbers, natural, whole, integer, rational, irrational, that contain the number 0.255 repeating. Then the 5 is repeat. I don't know why they did 5 repeating. They could have just done 0.25 with this 5 repeating. I don't know.
Didn't you make this?
Just to show that it's repeating.
I don't know. Just to show that it's repeating. Anyway, okay, so let's start with, it is a real number to begin with. All numbers are real numbers, so we're going to start with that one. Okay, then we have to decide, is it rational or irrational?
It's rational.
It's rational, okay?
It's only rational.
And then from there, we have to decide, is it an integer?
No.
No, then we get to stop. We don't have to go any further, okay? But that decimal repeats, so it is a rational number. Got it? That contain that number. There you go. Good?
Mm-hmm.
All right, number 2 is a fast one. Identify whether or not the set represents a function. There are 5 coordinate points there. Is that a function or not a function?
Function.
Yes, why?
Because nothing in the X repeat.
No
Yes,
X repeat.
no x's repeat. That's the rule, okay? The y's can repeat all they want. None of them do, but the y's can repeat. If the x's repeat and you graph it, it won't pass the vertical line test. So it's kind of along those same lines. If the x repeats, it doesn't pass the vertical line test. So that's the whole reason why, okay? Good? All right, number 3, domain. Let's talk about things that screw up domain. Okay, what do I not want to have ever happen?
0 on the bottom.
Division by 0 and
Negative square root.
negative square root. Which one do we have to worry about?
Both.
Both of them. Yuck. Okay. All right, here we go. Find the domain. All right, let's do division by 0. That one's the easy one, okay? This one is easy to figure out. So, dividing by 0, I don't want to have 0 on the bottom. So what can x not be or t not be?
3.
T minus 3 can't be 0, so t can't be. If I add the 3 over, t can't be 3. Okay, great.
X has to be greater than or equal.
That's the easy part. This is the easy one. The hard part is the square root part, okay? Yeah? Okay, so we know, let's say another way of looking at this is that t minus 2 has to be what? What does t minus 2 have to be?
Greater than 2.
Greater than 0.
Or greater than
T minus 2 has to be greater than 0 because you can't have a negative inside of a square root. Can it be equal to 0? Can you take the square root of 0?
Yes.
Yeah? Okay? Does that make sense? Was that hard to like t minus 2 has to be greater than
Are you
0?
gonna leave that as your answer?
So if I add 2 over, that means t has to be greater than or equal to 2, right? If you need to think about that on a number line, like 2 is here, 3 is here, 1 is here, right? Can I plug 1 into this equation?
No.
1 minus 2 is a negative. Can't take the square root of a negative. So it has to be 3. 3 minus 2.
You can't even
You
do
can't
3.
even plug 3 in.
You can't, yeah, technically. Technically, you can't plug 3 in. So let's say 4, right? Okay, so those two combined together give me my domain. So it has to be greater than 2, but it can't be 3 exactly. It could be 2.9, or it could be 3.1, but it can't be 3 exactly, okay? So that one has all of them. I think, don't quote me on this, but I think the one on the test only has one or the other, like domain errors. You don't have to combat both of them at the same time, right? But I gave that to you on this example so you're prepared for both, okay? Got it? All right, now we get to some easy ones. Write an equation in slope-intercept form. Okay, what's slope-intercept form?
Y equals mx plus
Y equals mx plus b. Okay, and the line passes through these 2 points. Okay, where do I start doing that if I'm given 2 points? Find the slope first. Okay, slope is m, and how do you find m with 2 points?
y2 minus y1 over x2 minus x1.
Yep, y2 minus y1, x2 minus x1. Make sure the y's go on the top because it's rise over run. Okay, what's your second y?
2. Or no, negative 4. Negative 4.
Y.
Five.
Y. 5. Ha. Minus 2 over second x. 2 minus a negative 4. So 2 technically plus 4. Okay, 5 minus 2 is 3. 2 plus 4 is 6. So the slope is 1/2. Y equals. If I'm going too fast on some of these, please, please, please say like, oh, hold on, slow down. What did you just do? And ask. Okay? Because, and I tell this more to my algebra kids than I do to you guys. You guys are pretty good about asking questions. But, like my algebra kids, just write down what I wrote down, thinking that like, even if they don't understand it now, like it'll just speak magic to them on the test. It doesn't work that way. you get to the test and like even though you have it written down step by step, you still struggle. Okay, how do I find B now?
Plug in one of the.
Plug in one of the points. Which one would you like to plug in?
2, 5.
2, 5, because I don't like negatives, right? Make sure you're plugging the 5 in for y and the 2 in for x, right? What is half of 2? 1. Okay, then I subtract that 1 over. So B is 4. So final answer, y equals 1/2 x plus 4. Okay, they give these problems to you like mad on the ACT. I swear one year I had like 4 of them. We're all writing slope-intercept form equations.
I only have
I didn't get any.
You didn't get any?
I just have
Oh
one.
my gosh,
so
they always
stupid.
ask you this. Or they ask you to find slope, or they ask you to find distance,
No,
or things
I
like
didn't
that.
get any of those.
Okay. Well, you did
I
not
didn't
luck
have
out
any
then.
distance,
No,
but
I didn't.
I have one.
All right.
I didn't get any of them.
Okay. Number 5 is kind of a similar one, but they're giving you the equation of some function right here, and they want one that's perpendicular. So let's talk about perpendicular versus, I might on the test instead ask you for parallel, but it's the same concept, okay? So you're going to do them the same way, except perpendicular. If I give you perpendicular lines, you're going to use what?
The reciprocal.
The negative reciprocal of the slope. Okay, so what's the slope that I have right now?
1/3.
M original is 1/3. So I want my new M. M new is going to be, what's the reciprocal? Oh, negative reciprocal is -3. 1/3 flipped is 3, and it's made negative, so -3. Okay, if I say instead, let's do parallel,
Same thing.
you use the same slope. So your original M is the new M. Same slope, okay? So that's fair game. Make sure you're paying attention to whether say perpendicular or parallel, because on the test I might say parallel instead. I don't remember, okay? All right, so now where do I start? Y equals, we know the slope is -3x plus what?
B.
B. Okay, what do you do? What do you do with this -2? Where does he come into play? He doesn't. You cross him off. We don't use him, okay? Because your new equation is going to have an altogether new intercept, right? Okay, so I'm going to plug -1 in here and 6 in here. 6 equals 3 times -1 is 3 plus B. Subtract the 3. What's B? B is 3. That's a lot of 3's. So final answer, y equals -3x plus 3. Was that too fast?
No.
Is that okay?
Yes.
Okay. All right. Good?
You're gonna die?
All right, here's my sequence. Find the first 4 terms of the sequence. This is my formula. This is not too bad. That's my formula that tells me what I do next, okay? So they give me the first term of the sequence. They have to. I have to find the first 4 terms. So there's the first one, the second one, the third one, the fourth one.
I did not do it.
Okay?
I remember doing it. I don't remember how to. We did
All right. So my function is 1/2 x minus 4. So that means whatever my first term is, I plug that number in for x. Then whatever my second term is, I plug that number in for x to get the third one. I keep plugging different numbers in for x, right? So here I'm going to plug -2 in here to begin with, okay? So I take 1/2 times -2 minus 4. I'm taking this -2 and I'm plugging it in here.
Oh.
Yeah? Okay, to get the second term. Half of -2 is -1 minus 4. So the second term is -5. Then I do the process again. But this time, instead of plugging -2 in, I'm going to plug -5 in. Okay, and this is not going to be so nice. What's half of -5?
2.5.
-2.5 minus 4?
6.
-6.5. Okay? Then I do the process again. I do half of -6.5 minus 4. I'm just doing the same process again, but just using a different input value each time. Okay? Half of -6.5 is -3.25. And that is -7.25. If you need to use a calculator, you can. Whatever. I don't care. Okay? Those are my first 4 numbers. Starts with -2, then goes down and down and down from there. Got it? Yeah, perfect. Okay? First 4 terms. This is just my sequence that I have going on right there. Okay? All right, 7 is also about sequences, arithmetic or geometric. Do you remember the difference between arithmetic and geometric sequences?
One
It's
is
just
add
x and x
subtract,
squared.
and
Arithmetic is you're adding or subtracting.
multiplying or dividing.
Yep, and geometric is multiplying. Now, technically it's also dividing, but they will only ever call it multiply because, like, instead of divide by 2, they will say times 1/2. Okay, so they'll only ever use multiply when they're doing arithmetic or geometric. They will switch it around to make it multiply by a fraction. Okay, so you're either adding, subtracting, or you're multiplying. Okay, and then it says find the common difference. So if it's arithmetic, you're going to find the common difference. If it's geometric, you're going to find the common ratio.
-1/2.
Okay, so we need to decide what we're doing. Are we adding the same thing each time, or are we multiplying by something each time? You're multiplying, okay? So, first answer is that this is geometric. I've answered that question. Then I have to find the common ratio. Ratio. And you are multiplying by -1/2. I'm just going to put -1/2. -1/2, okay? You're multiplying by -1/2. Do you see how that works?
Yeah.
Yeah, you see what you're multiplying by? Okay.
Pretty easy, breezy, beautiful.
Easy breezy, beautiful. Perfect. Common ratio. Got it? Beautiful, beautiful. Okay. All right, number 8. Determine whether the lines are parallel, perpendicular, or neither. Okay? The lines are parallel if they have the same slope. I'm going to write it over here. If you don't want to write it down twice, you don't have to. But same slope. Perpendicular is when the slopes are negative reciprocal. If you don't want to write that down again, you don't have to, but negative reciprocal slope. Okay. All right. I have no idea what the slope of this thing is.
We gotta find it.
We got to find it. How do you find it?
You get the
Y
y
by
on the
itself.
other side.
Get the y by itself, right? Let's solve for y, okay? So, how do you want to solve for y there? Should we kick the other two things to the other side?
Yeah.
So kick those to the other side. So y is the only thing left over here. Okay, if I kick those two to the other side, can you do that at the same time?
Yeah.
Okay, what will it be? Negative 2x, so this guy becomes negative, and then this 2 becomes plus 2. So that's that equation. Do you see how that works? Okay, now let's solve this guy. Let's get this y by itself. So if we kick this to the other side and the 18 to the other side, I will have 2y equals
-4x.
-4x minus 18. Okay, then divide by 2. I still have to get y by itself. So y equals -2x minus 9. Okay, so those are my two equations in slope-intercept form. Are they parallel, perpendicular, or neither?
Parallel.
They're parallel. They have the same slope. Parallel. Okay. If you end up getting neither, I would check to make sure you did not make a mistake. Right? Does that make sense? If you ended up getting neither, I would check to make sure you didn't actually make a mistake. Right? I'm guessing the fact that we got parallel, like, we probably didn't get that by mistake. But if you got neither on there, like none of them match up, I would check to make sure you just didn't do some math wrong. Okay? It could be neither. I have no idea. But just make sure that you didn't make a mistake. So parallel is the correct answer for that one. Good? All right, what are we at now? 9? Oh man, we better get booking. Okay, the sum means you're summing them together, okay? We're starting with the number 1. We're plugging that in, and we're plugging in 2, and we're plugging in 3. So we will have 3 numbers to add together, right? Here's what I get when I plug in 1. Here's what I get when I plug in 2. Here's what I get when I plug in 3. Yeah? Plug in 1, plug in 2, plug in 3. Got it? All right, if I plug in 1, I would have -1/3 to the first power, which is -1/3. Okay? If I plug in 2, I would have -1/3 to the second power. What's -1/3 to the second power?
-1/9.
-1/3 to the second power is the same thing as -1/3 times itself twice, right? So positive 1/9, right? Okay? And then I'm going to plug it in again. I'm going to take it times itself again. What's 1/3 times 1/3 times 1/3? Negative 27th, I think. 3 times 3 times 3 is 27. Okay, how do I add those together?
Find a
You
common
have to
multiple.
do the same denominator.
Same denominator. What's your common denominator going to be? 27. So I have 1 over 27 here. If I change this to 27s, that will become
-6/27. Sorry, kids.
3 over 27.
Oh, your
I-
final answer.
yeah.
Okay, don't listen to Kyle. He's got the final answer. This is 3 over 27, positive, and this is negative. What's 1/3 in terms of 27?
9 over 27.
We multiplied by 9. Here we multiplied by 3, right? 9 over 27. So I have negative 9 plus 3 minus 1.
Oh, it's white.
-7.
Negative 7 over 27.
Yes, sir.
There you go. Negative 7 over 27. Perfect. Okay? Good?
You said bad word.
Great. That's a summation.
That's
Okay?
great, but that's
All right, chapter 2. We got to get going.
What?
These ones are fast. Come on. This is all factoring.
10 minutes.
Yep, we've got 10 minutes to do 5 problems. Okay? Use a graphical method to find all real solutions of this equation. Okay? All right. How do I use a graphical method to find all solutions of that equation?
You graph it and then zoom in.
How do you graph it?
We have
Put
to
it in your
graph it.
calculator.
Put it in your calculator. How do you put it in your calculator? Where do you go?
Put it in y equals.
Y equals. Y1 equals. Okay? Type in. Type in on your graphing calculator x to the 4th plus x minus 3. Okay? I'm going to put in here star change window. You may have to change your window back. I always start with negative 10 to 10. Okay? And then graph. And locate the zeros. So you're just going to zoom in. Okay? This thing, if I graph it, looks something like, or Kyle graphed it. Okay? Looks something like it goes down and then it kind of like flats here, there, like that. That's kind of what he does. Okay? So I have to find this spot and I have to find this spot and we zoom in. And this guy right here is at like, I don't know. Something like, I don't know, negative 1.44. Close to that, right? That's one of my zeros. Okay, the other one, the other zero on the other side looks like, I don't know, like 1.16 or something like that. Something of that nature. As long as you're close, that's fine. Okay?
Mine won't work.
Does it say error?
No, it says
Did you just call Jason an
invalid
idiot, Kyle?
dim.
Invalid dimensions? It's probably because your window is wrong. Go back to your window and change your window. Negative 10 to 10, negative 10 to 10.
That's not very nice, Kyle.
Negative 10 to 10.
Negative 10 to 10, negative 10 to 10.
That's why I have.
I'll fix it here in a second. Okay, number 11. Let's solve by factoring. I can't factor them yet though. Minus 14 over. So x squared minus 5x minus 14 equals 0. Okay, now what? What's this? What is this thing?
X minus 7.
Simple trinomial.
He is a simple trinomial. Let's factor him down. Multiply to get 14, add to get
X minus 7
5.
plus 2.
X minus 7, x plus 2. Does that work? Okay, that means x equals 7 and x equals negative 2. What are those two things telling me?
Those are the zeros.
Those are the zeros, right? Okay? Or the x-intercepts, right? We've just found them by factoring rather than graphing them. If you had no idea where to start factoring that thing, you can graph it just like we just did, right? And just find those places where he crosses, right? There's a shortcut, like you have a graphing calculator, you can use it. You can use it to check your answer if you want, right? Okay, solve this one by factoring. What is this thing?
Complex trinomial.
Complex trinomial. Okay, how do we do a complex trinomial?
Multiply.
4 times 2 is 8. Okay, I want factors of 8 that when I add them will give me 9.
1 and 8.
1 and 8, I'm guessing. Okay, now we write our 4 pieces. So 4t squared. You want to go plus 1 or plus 8?
Plus 1.
Plus,
8.
you want to go plus 8?
8.
Okay, we'll go plus 8. That's fine. I don't care. Plus 8t t plus 1t plus 2. Then what do we go? Where do I go from here?
Group.
Group. Okay, what are you going to take out of the first group?
14.
4t. Am I going too fast? Okay, left over is t plus 2. What are you going to take out of the second group? You have to take something.
1.
1. We're going to take a 1 out. Okay, left over is t plus 2. If not, I did it wrong, right? My two groupings are t plus 2 and 4t plus 1. Now what?
Well, what the heck did you guys do?
What we're supposed to do, Kyle. What did you do?
Did you put the 1 first?
You
Or the 8?
idiot. And I can't do it.
I don't know, man.
Got a lot.
Here, t equals -2. What does t equal over here?
-1/4.
-1/4. Can you do that in your head?
Yep.
If you can't, write it out. But if you can, do it in your head. Okay?
Get away from me.
All right. All right. 13. How do you solve this one?
If you touch me,
Not quite. It's missing its middle term. So these are actually easier. It's not going to be a trinomial.
Add the 8 over,
Okay, let's subtract the 8 over.
or subtract the 8 over, like
Okay,
I said.
-3w squared equals
Divide by -3.
-28. Ugh, this is going to be ugly. Divide by -3. It makes it easier when you're missing that like b term, right? So w squared equals 28 over 3. We're just going to leave it as 28 over 3 because it's ugly. Okay, then what? Take the square root. Okay, what's the square root going to look like?
Plus or minus?
Plus minus?
You have all your classes published on Apogee Rooms?
Yes.
You got them all
Yep,
published?
yep.
How many did you have on there, like 30?
What? 30? No, all of my, no, I had 6. I had 7. 7, yeah. Yep, I had 7 on them.
We're gonna go live in January.
Yep, that sounds good.
Parents, and then they email you or message you, and then your Google Classroom.
Perfect.
Like the Guardian View and Parent Classroom, you can't see them.
So if I've posted to Google, because I did it that day, if I've posted to Google Classroom since, should it have shown up in that Apogee? I need to go back and look.
They haven't went live with it yet, so maybe on your end you can see it, but
I should go back
the
and look and
parents'
see and make
version,
sure
so
that it
like-
showed up. Okay,
the parents will get an email, download the school app, you can log into the school app,
cool.
and then there'll be 3 dots, and then they can pick out all their kids. So like
Nice.
Luke's whole schedule will come up.
Right,
If his mom wants to text
cool.
the teacher,
That's
they can
awesome.
write into it, so.
That will be really cool. I'm gonna leave it just as the square root of 28 over 3. If you want to try to break it down or do whatever, I don't care. That's fine. But that's what the zeros will be. Okay.
It's
All
like
right.
9.3 then.
What?
Oh, it's 9.3.
9.3.
9.3 is what it is. When you take the square. Okay. All right. Do we remember how to complete the square?
no.
No.
This is an ugly completing the
Do
square.
we actually have to complete the square? Can we just like?
Can I change the problem so that it's not so ugly?
Yeah.
Yeah.
Can I put a 2 right here?
I do
I'm
have a
gonna put a
question.
2 right there.
Say on the final, and you give us this,
No.
do we actually have to complete the square? Because I can just grab
Can
it.
we just solve it without?
Yes, you
completing
actually
the
have to
square?
complete the square.
Why?
But what if I just don't show my work?
No, mama.
Then I take off half.
Your mom.
Whatever.
That's bogus.
Sorry.
Your
Bogus.
dad,
Okay.
sister,
Complete the square. Step number 1.
Your cousin, your sister, your wife, your
W squared minus 2w plus blank equals, I move the 1 over,
hamster,
1 plus
and
blank.
stupid, just
Okay.
like you.
I was not.
That was step number 1. Move the 1 over. Okay? All right, step number 2.
I know I don't hear it.
I want to break this down as a trinomial, so I want to multiply to get this number, but when I add them, give me this number.
Oh, this.
So, I don't know what the blank number is. Multiply to get that number, but add to get -2. What 2 numbers add to get -2 that are the same?
-1.
W minus 1 and W minus 1. Okay? Now, if I do that, what number goes in the blank? Positive 1. -1 times -1 is positive 1, right? So 1 goes here, 1 goes here. So on the right side, it is 2. Step number 3. What's step number 3 look like? What is W minus 1 times W minus 1?
W squared.
No.
Wait.
No. W minus 1 squared equals 2? Isn't that another way of writing W minus 1 times W minus 1? Now what? Take the square root. I'm going to take the square root. Okay? All right, so over here, W minus 1 falls out. What's the square root of 2? Plus minus square root of 2. Last step, add the 1. Can you add the 1 to the 2? No, so I just write my answer as 1 plus minus square root of 2. There you go. There's my zeros. How many answers are there? How many zeros do I have? 2 technically. Okay, last one, quadratic formula. I'm gonna write out ABC, and I'm gonna write out the quadratic formula. Okay, is everything on the same side? Do we have to move anything?
Yes.
Everything's ready to go. A is 4, B is negative 8, C is 1. Write the formula down. Negative B plus minus square root B squared minus 4AC all over 2A. Okay, then let's plug stuff in. All right, what will negative B look like?
8.
Positive 8, right? Plus minus the square root. What's B squared going to be?
4.
64 minus 4 times A times C.
8.
Okay? All over 2 times A.
Got my calculator.
All right, yep. Okay, so we've got 8 over here. Let's do our square rooty stuff, okay? What is, oh,
This was
Okay.
number 15.
Goodbye.
Number 15.
oh, this is number 15. Okay, so we'll, if you want to finish that one for tomorrow, we'll go over the answer tomorrow, and we'll continue on. There you go.
I don't think it's up.